If it's OPC, we've got it covered. Welcome to OPC Expert Plugged In, where we break down the tech and tackle real-world challenges. Let's dive in.
Welcome to the deep dive. If you're dealing with industrial automation, getting different systems to talk, it can be tricky. You've got OPC DA, OPC UA, lots of standards.
Yeah, it's a real headache sometimes. You have old gear, new gear, and they just don't speak the same language natively. Getting that data flowing smoothly between them, that's often the bottleneck.
Exactly, like trying to get data from an old PLC into your, fancy new monitoring system.
Right, and that's where something like OPC Bridge comes in. It's actually a feature inside OPC Expert software.
Okay, OPC Bridge. So its job is basically to fix that communication problem, connecting DA and UA servers.
That's the core idea, yes. Our mission today is really just to unpack what this OPC Bridge feature is, how it works, based on the info we have about it. So fundamentally, what's it doing?
What's the mechanism?
Well, think of it as a translator. It creates a seamless pass for data between an OPC DA server and an OPC UA server. The tagline they use is pretty apt. Effortlessly transfer data between OPC servers.
Effortless. I like the sound of that. Industrial controls can get pretty complex. So how easy is it for, the actual user? Are we talking complex setup here?
Actually, no, that seems to be a major focus. It's designed with a drag and drop interface.
Drag and drop.
Yeah, you literally see your data points on one server, drag them over to the destination server in the interface. It's meant to be very visual, very intuitive.
Okay, that does sound simpler than scripting something custom. But, industrial settings, things go wrong, connections drop, servers hiccup. How does the bridge handle, instability?
Good question. Reliability is obviously paramount, so it has built-in automatic fault detection, meaning it's constantly checking if the connections are healthy. If it spots a problem, it tries to handle it automatically to keep the data flowing without interruption, or at least minimize it.
So it's actively monitoring. That's good. What if, say, one specific connection gets really slow or hangs? Does that jam up everything else going through the bridge?
That's where the multi-threading comes in. Each server connection runs in its own separate thread. Think of it like separate lanes on a highway. If one lane gets blocked, the others can hopefully keep moving. So a problem with one server connection shouldn't drag down the others.
Right, isolation. Makes sense. The material also mentions redundancy. How does that fit into the reliability picture?
Redundancy is your backup plan. You can configure a secondary data source or connection. If the main one fails, maybe the server goes down or the network path breaks, OPC Bridge can automatically switch over to that backup.
Failover. So trying to ensure continuous data flow even if something breaks.
Exactly. It's about maximizing uptime.
Okay, so multiple ways to keep things running. What about network challenges? Firewalls are everywhere in industrial networks. How does data get through those?
Yeah, firewalls can definitely block standard OPC communication. OPC Bridge apparently has a clever trick for this. It can dynamically switch between asynchronous and synchronous communication methods.
Async and sync. Explain that a bit.
Well, async is like sending a message and not waiting for an immediate reply. Efficient, but sometimes blocked. Sync is more like a direct call, requiring both ends to be active. If the async path is blocked by, say, a firewall, OPC Bridge can try using sync to push the data through. It adapts.
Interesting adaptation. Now thinking bigger picture. Large plant, hundreds, maybe thousands of data points to bridge. Setting them up one by one via drag and drop sounds tedious, even if it's easy.
Right. For scale, they've included a bulk configuration feature using CSV files.
Like spreadsheets.
Exactly.
Yeah.
You can define all your bridge connections, all the data points, sources, destinations in something like Excel, save it as a CSV, and then just import that file into OPC Bridge. Sets up potentially hundreds of connections at once.
Okay, that's crucial for large systems. Saves a ton of time.
Yeah.
What about compatibility? Does it work with any OPC DA or UA server, or are there limitations?
The goal seems to be very broad compatibility. It's designed to work with pretty much any OPC DA or UA server that follows the standards, regardless of who made the server. So, yeah, bridging legacy and modern systems is kind of the point.
Now, installation. Industrial systems are often sensitive. Does installing this software involve deep system changes? Registry edits? That kind of thing worries IT folks.
That's another interesting point. OPC Expert, the software containing the bridge, apparently requires no installation in the traditional sense.
No installation? How does that work?
You can essentially just run it. It doesn't modify the Windows registry. This is a big deal because it minimizes the risk of messing up existing configurations or causing conflicts. Much lower risk deployment.
Okay, that definitely lowers the barrier to trying it out. All right, as we wrap this deep dive, what's the single main takeaway message about OPC Bridge?
I'd say the key thing is OPC Bridge is a purpose-built feature within OPC Expert, designed specifically to make data transfer between different OPC servers, mostly DA and UA, straightforward and reliable in industrial settings. It's about making a complex integration task much, much simpler.
Simple and reliable. Got it. And a final thought for you, the listener. If you could have truly seamless data flow between all your industrial systems, old and new, what new doors might that open? Think about the possibilities for better monitoring, tighter control, smarter optimization in your own operations. What could you achieve then? That concludes this deep dive. Thanks for joining us.